Welcome and thank you for coming to our webinar. Today, we would like to introduce you the latest development and improvements of Idea Statica in concrete. We are using GoToWebinar. You are all in listen-only mode. Please feel free to input any questions into a chat window. We will answer them immediately into the chat or at the end of this webinar. My name is Martin Rolny, and I have two of my colleagues here today, Jana and Filip, our product engineers, who will show us some examples during this presentation. The most of our today's presentation will be about Idea Statica Detail, which brings simple design and code check of all types of beam details, wall details, diaphragm masks in minutes. Let me check the existing tools for design of discontinuity regions. Of course, there is a quite well-known strat and tie method and a lot of programs based on that. But probably, as you know, it enables only to check ultimate limit state. You need to define a model of strat and ties, and unfortunately, in fact, nobody knows which model is the correct one. There is also, or there are scientifically oriented programs like Abacus, Midas, ANSYS, and so on. But from my point of view, from my point of view, these tools are, let's say, for very skilled users. You need to spend a lot of time by inputting of the model, and finally, there are no code checks inside these softwares for these special discontinuity regions. So that's the reason why we have created a new tool, Idea Statica Detail, which is based on a fine element method. It contains all scientific models inside, and it can create the analysis model automatically. So user just needs to spend a few minutes with the input of the project and can immediately check the concrete details according to the Eurocode for both ultimate limit state and service limit state. We are cooperating on development of this project with one of the top universities in the world, ETH Zurich. We started together on this project in October 2016, and we put a lot of effort into preparation of material models, coding of the software, and especially we spend a lot of time with verifications of our solution. So what is coming in Idea Statica Detail version 9? The big improvement is the implementation of the serviceability limit state checks. So we have now available stress limitation, corrective, and deflection checks. We improved also the reinforcement input, so we can define the reinforcement into more members. We add our mandrels in reinforcement. We have improved the DXF import of in general, as of the members and as well of the reinforcement. We have the possibility to export a 2D DXF files from the bill of material, and we also improved the output report. The next big development was about the improvement of the link with existing Idea Statica beam. So now we support the export of construction stages and composite crossed sections. And so now we are coming to examples. Jana will show us the first one. It will be a beam with an opening. Then the second will be about a prefabricated wall design and will be presented by Philip. Philip also will tell us more about improvements in Idea Statica beam. So where we have developed or implemented a lateral instability check of slender beams. And we have also added an option to set elastic module in construction stages. So now I will give a presenter to to Jana, and she will show us the first example.
Thank you, Martin. Hello, everyone. So I will share my screen and we can immediately start the first example. It will be quite an easy example where I want to show you I will focus on the new features in version 9 compared to version 8. So I have already started Idea Statica Detail and I can set a new project. I will leave the concrete grade like the default value, as well as the reinforcement type, and also the concrete cover on 30 millimeters. Then I will choose one of our templates. It will be member 1D, from which I will choose the opening type. And the software automatically creates a project with several items depending on the template. So in my case, there are 2 items. The first one is member itself, and the second one is the opening. So I can change the cross-section of the member, and I want to make it I-shape with hinged flanges. My cross-section will be a little bit narrower and taller. So I will just change a few parameters according to the figure and I will confirm. Next, I want to shift the opening to the center and also it will be a little bit bigger. So I will change the diameter and easily by this master and insert point, I can define the position of the opening, which is in the center. So I will just select 0 Z position. Okay, I think that's all from the geometry, and we can move to have a look on loads. So here you can see there is a difference compared to version 8, as I have already 3 combinations created by the template. In version 8, there was only 1 combination. The reason is simple. It's because of the implementation of serviceability limit states checks. Therefore, we need more combinations. So the first one is the combination for ultimate limit state check, and the other 2 ones are SLS combinations. The first one is quasi-permanent and the second one is characteristic combination. You can easily change the coefficients of load cases in the combination table, but I will leave the default values for this example. There are also 2 load cases created, and now I will have a look at the load inside the load case. So for the LC1, which is the permanent load, I will change those values. I will input the internal forces at the point of opening. So I will change the X position, and my opening will be just in the midspan. So I will put 0 shear force and maximum bending moment. In load impulses, we can define some distributed load. I will leave the value on -10 kilonewton per meter. Now I will change the load case to LC2, which is variable load case. And again, I will define the internal forces just under or at the point of the opening. So I will define X position and shear force plus bending moment. And I can change a little bit the line load on -5 kilonewton per meter. So now I can have a look back on my table of load cases and combinations. You can notice that the load cases are switched off. It means that the calculation will not be performed for these load cases. If we are interested in results of these load cases, I can just easily switch them on, but due to some time consumption, or it will be the calculation will be faster if we are interested only in the results of combinations. Okay, so the next item of the left three is reinforcement, and I can start the definition of reinforcement, or I can just change the settings of already created items according to template. The first item in the list are the stirrups. I can change the diameter of stirrups and also the spacing. So let's say I want to have stirrups in distance of 450 millimeters. So you can see the stirrups were changed. The second item is the reinforcement around the opening. This item will not be used in my example, so I can easily switch it off or delete it if I'm not interested in this reinforcement at all. So now the second item, or the third one, are the bars at the bottom face. These can be also a little bit reduced. And the last item so far are the rebars at the top face. I can also make them smaller. And now I will show you one of the new feature of version 9. I will import the reinforcement from DXF file. So I have prepared the shape of my reinforcement in AutoCAD, and I can easily select the bars, confirm, and you can see that there are two new items in the list. And what is new is that now it takes into account also the thickness of the line, and this parameter is then the diameter of the rebar. So if you set the thickness of the curve in AutoCAD, then this will be the diameter of your reinforcement bars in Idea Statica, and this number is imported as well. Okay, so I think I am done with the definition of the reinforcement, and I can start the calculation. It will take a moment because there are 3 nonlinear combinations, but you can see now that there are more tabs over the table of results compared to version 8. The new tabs are the stress, crack, and deflection tab, which correspond to the serviceability load, serviceability limit states. So these results will be the new ones that you couldn't see in the last version, and I will focus on them. Then you can also find all the results that were present in the last version. It means all the code checks of strength of concrete, strength of reinforcement, and the anchorage. Okay, so the calculation is done, I can see that there are only green signs, which means that all the detail fulfill the code check. So the first view that we can see is the overall check of the member. I can just maybe adjust a little bit the filter, so we will display only the part of concrete that are in compression all over -2 megapascals. These filters can be adjusted in the top ribbon. So the first table is the overview of the results. We can see that the first part of the table corresponds to ULS. We can select the display of strength of concrete, strength of reinforcement or anchorage length. And if we want to see the overview of SLS checks, we just select that line in the table, and we can choose between stress limitation and crack width. But all the detail results are present in the corresponding tab. So you probably all already know the strength tab, where there are results for concrete. In the top ribbon, we can change the characteristic that is displayed. So for example, I can display the principal stress or the principal strains or the reduction factor Kc. If I want to see the results for reinforcement, I will choose that line in the table, and I can display the results for each bar of reinforcement. Again, different characteristics can be changed in the top ribbon. So for example, the stress in the rebar or the strain. Third tab is anchorage. That checks the utilization of the anchorage stress. And now we can move to the serviceability limit state tabs. So the first one is the state of stress limitation. You can see that for concrete, the combination C2 was taken into account, while for reinforcement, the combination C3. And I can display all the results, again, concrete or reinforcement, for different items of the reinforcement. Next step is the check of the crack width. All the values in the figure are always they correspond to different rebars, and they are the value of the width of the crack is compared to the value that is set in the top ribbon. So my limit crack width is 0.3. If I want to have more strict criteria, I can set, for example, 0.9, and you can see that there are already cracks that don't fulfill this check, so they are over this limit. So you can select the limit in the top ribbon. The last step of SLS checks is the deflection. I have to mention that this example with the trimmed end is not really convenient to display the deflection, as the beam is continuous on both sides, so we are not really able to define some constraints at the end. So for that reason, we are assuming such a constraint at the left end of the beam. In Philip's example, the deflection will be displayed in much better way. Now we can move to bill of material, and the nice new feature, very useful, is the export to DXF file. I can just save the DXF file, and you can see I have already opened the file in AutoCAD. You can see that I have all the items of reinforcement present in the drawing, so you can continue working on that drawing. And the very last step of the design is the definition of report. There are some new features that were implemented in version 9. Some of them are known maybe from Idea Statica connection to some of you. So now you can easily change the order of different items of report by drag and drop style. And always, if you change something in the report, you refresh in the top ribbon and the document is updated. If I don't want to display all the results, I can change the settings. And for example, I will display only the strength of concrete and strength of reinforcement. I can refresh the document and it will be, of course, much shorter. If I want to save my settings of report, I can do it easily by export in the top ribbon. You can see that I can save the settings in a XML file, and if I change it back to default, you can see that by import the settings is back again. So you can share the settings among your projects. Okay, and I think that's all from my example. Now I will pass the presenter to Philip, who shows you the prefabricated wall.
Yes, thank you, Janka. So it's my pleasure today to show you this nice example of prefabricated wall. You maybe know this example from literature, so I'll try to comply with that. And to do that, we will use the general input in Idea Statica Detail. So by running a new project or new model, I will use the general input like this, which will load a blank model or a blank project. We usually use this to import the DXF files, but in this case, it will be a very brief example with 2 wall elements. So let's add the first one. Let's put in its dimensions, so 3.5 on 3 meters, and let's make it thicker, so 0.3 meters of the thickness. And we will add second element, which will be again the wall, and we will align it very easily to this edge. So we'll use master point number 2 and insert point number 1 like this, and adjust its diameter to 1.5 on 1.5 meter like this. These 2 elements will be meshed together and connected, so we don't have to worry about dividing our models into separate wall elements to make it very easily to input. Okay, we will need one more opening, and we'll again adjust its position by master and insert point. So these points will be number 8, both, pardon. And the distance between them will be 1 meter. And of course, we need to adjust the size, so 1 meter wide and 1.1 meter high. And we have the desired geometry. Of course, we need 2 things to complete the geometry. First one, as the software warns you, we need to add some boundary conditions or supports. Let's use point distributed ones. which first one will be on this side of the edge with X and Z direction fixed. And let's use copy button. Let's switch the wall element, and not from the beginning, but from the end, like this. And maybe let's release X constraint like this. So we receive something like a simply supported wall system. Okay, the last thing which I need to add is some device to transfer the loads, because I will apply a point load at the top edge. So from the last part or last section for load transfer devices, let's use the bearing plate, which will be 0.4 meters wide, and the thickness will be 40 millimeters. 40. And let's also move it 1.5 meter from the end of this edge, like this. Okay, we finished our geometry very quickly, and we'll proceed to the loads. You can see that in a blank project there are no load cases and combinations defined as in the templates. You could see that in a previous example. But let's start with the definition of first load case for permanent effects, and let's introduce 1 point load, which will be minus 100 kilonewtons on a bearing plate. We will make one more load case for variable effects, again 1 point load minus 250 kilonewtons, and we'll introduce 3 combinations. So the first one which we add will be the ULS. The second one will be the SLS. So let's change it, and it will be characteristic combination. And the last one will be SLS, but quasi-permanent. Now I want to change the partial factors for these combinations, and I don't need to do it separately. I can do it when I have as many combinations as I want. So you can see that I can change it for the ULS, for a variable, and maybe for a quasi-permanent, let's decrease it by psi factor, and the final factor will be 0.6, like this. And the last thing which I want to maybe repeat is that I want to uncheck the load cases, as I don't wish them to be checked. Okay, let's reinforce the example. And as I mentioned, some of you may know this example from the literature and know how to reinforce. Again, to repeat, what we actually can do is to use some design tools. So maybe let's use linear analysis, which basically shows the areas under compression and under tension, and I can have these results under light or highlighted in under while I will input the reinforcement, or I can switch them off. Again, you can see that we will reinforce the bottom edge of the wall, and maybe these 2 corners. So to do that, let's use few items. First, the basic one is group of bars, and in the first item, let's use some smaller diameter, so 4 pieces of diameter 14 in 2 layers, and let's change it to bent at both ends. You can see that now, according to this setting, the whole length, it's stretched along this whole length of the wall number 1, but I actually can extend it very easily to the second member. To do that, I will use extension, and I know by this red orange arrow that it shows me from the beginning to the end that I want to extend the end, and I can do it in 2 ways. Either I can extend it by an absolute value, or I can say find the outer edge for me and apply its length. So you can see it has been calculated automatically, and it very helps in most of the cases when you have shortened edges or you want to continue in next element. Okay, let's add 2 reinforcements items for the opening. So another group of bar, let's change it from the wall to opening and edge number 3. And also, let's copy that to edge number 4, like this. And the last one, which I want to show you, is not the very necessary one because you haven't seen the tension in these areas. But I want to show you a few new features which are actually in the software. So again, I will use group of bars to do that job, and I will change the definition on more edges. As of now, you are able to, for instance, reinforce it like this, so you could continue in one member, and according to the given edges, you would have seen the shape of the reinforcement. Now we have the new possibility called outline of all members, which will find the edges on the outline. And I can specify the polylines or definition of more edges through both segments. So let's change it to 2, 1, and 4 like this, and maybe shorten the distances like this. And you can see that I can easily move from one to the second element. Also, in previous version, in cases like this, you could see that these inner edges were in a perpendicular shape. There was a 90 degrees angle. So to improve the stress redistribution or the bond model in the roundings, we added the mandrels in the reinforcement. At first, it has the default setting according to detailing rules. So for diameter 16 and smaller, you can see that it's 4 diameters. Once I go up to 18, you can see it's 7 diameters. Of course, if I'm willing to, I can specify my own. So let's say I want to apply 20 diameters, and you can see it's bigger than it was or that is needed. So these are nice features, and let's proceed to the check. I will run the calculation, and I don't want to repeat my colleague, so I'll try to explain something else, because as you will see, that we have actually more models implemented as of now, because we can cover both short-term and long-term effects in the SLS calculation. What is it about? The first model is this one, this orange line, and actually we apply the permanent load and the short-term elastic modulus. Then we receive the crack width or the deflection for a short-term effects. Then we apply the variable load case and also the short-term elastic modulus, and we receive a total crack width for short-term or short-term total deflections. And the second model calculates the permanent load cases for the effective modulus, which includes the creep coefficient setting, and we receive the long-term crack width or long-term deflection for the permanent loads, and then we apply variable loads, but again with short-term elastic modulus. Of course, what this picture is trying to explain, the cracks or deflections don't need to be necessarily, how to say it, bigger or scaled in that same direction. So actually, the variable load case can, for instance, close the crack, right? So this arrow tries to simulate then that we can obtain both possibilities. And let's see how you can see these results in detail. Once I go into, for instance, crack, you can see all these columns, which I try to explain right now. And if you wish, for instance, this is the short term, this is the long term. So once I changed it, you can see that for short term, I should receive 24 millimeters, for long term, 26. And the extreme shows the worst from these two. And the same thing applies for the deflection. This is a very nice example to show the deflections. As Janka mentioned, this is at least determinate or undeterminate structure, so we can display the deflections. The only problem is with the models with trimmed end. So for instance, show it like this. Maybe 0.5 would be very nice. And again, I can switch between the results, and I can also, for instance, set some extreme. For instance, I want maximum of 2 millimeters of check, and you can see that it's recalculated automatically like this. Okay, I don't want to repeat all these results, which has been very nicely shown by my colleague, and I will end in the report, as you all need to at the end of the modeling. And there is a new feature, and it's the possibility not just to print the report, but you can now also save it directly in PDF or by a .dots file, which can be read, or it's a native file format for Microsoft Word. So let's say it's webinar.docx. And once you do that, the Word will be started automatically, and you can see the whole report there. You can work with it, and so on. So that's all from the news in the detail, which I wanted to show you. And I will continue with the news in Idea Statica Concrete and Pre-stressing, which are actually two new features. One is lateral instability for beams and elastic modulus input in construction stages. Both of these are to be found in Idea Statica Beam, and lateral instability can be also found in Idea Beam. So let's show it in Idea Statica Beam. This is some basic project which I created for this purpose. And the first thing you can do is that when you are in construction stages, you could specify the specific compressive strength of the concrete, and the equivalent time could be adjusted or calculated automatically. And these situations allows you also to input the concrete younger than 3 days. Once we do that, or uncheck that, you can see that the software warns you. Now we have the possibility to input the elastic modulus. So in the same way, let's say 30 gigapascals, and it's all recalculated based on these data. Okay, and once we calculate the whole model, we are able to input the data for the stability of the beams, and it runs according to the chapter 5.9 in the Eurocode 92.1 which basically covers two different situations, where one is persistent and the second one is transitioned. And there are two conditions, let's say they are like geometrical conditions. So there is a new tab in Navigator for concrete design, and I will use, let's say, one is on the crane, and you can determine the width of compression flange. So for instance, 0.6, the height, let's say 1.2 meters, and the length is 15 millimeters. Pardon, on the crane it's 14, and it's transitioned. And you can see directly if you satisfy these conditions or not. Let's say this will be the final setting, and it will be 50 meters and persistent, and you can see that different limit values are applied, and we satisfy both checks. This chapter will also appear in the report once I will do the whole example. And this is all from my side, and it's time for Martin to finish this session.
Okay, thank you, Jana and Philip, for showing us these examples. Now I would like to tell you something about changes in licensing. From the version 9, we introduce an automatic online form on our web pages for the trial requests. So you just need to fill the form, and you will immediately receive the trial activation code, and you can start your trial period. As you see, there are some limitations of the trial license. It can work only for 14 days. It's not possible to activate another activation key of the trial on the same computer. And there are some watermarks in the report and 3D scene. And you cannot, or you can in fact only just to print the report from the trial version. You cannot export it into the Microsoft Word file as Philip showed us. The same license request procedure is also available for the educational license. Of course, there are some difference to the trial one. It's valid for the 1 year. There are also some watermarks in the report and directly in the software. The same restrictions for the output about the reports. And what is also important, the project, once you open the project in the educational version, it's, let's say, marked as education, and it's even when you open it in the commercial version, it will work as an educational one. I will also tell something about the update of existing license from the version 8 to version 9. For the opening of the version 9, you need to new license file, which you will be provided by a local resource. We provide this to all customers with the valid maintenance. Once you received a new license file, you just need to load that in the license manager. You don't need to, let's say, reactivate it by the activation code. So that's all about the changes in the licensing. Now we can go through the questions you give us into the chat. I can see here the first question is, and it's about the mesh. So user asked us whether it's possible to modify the mesh of fine elements in the idea Statica Detail. So maybe I will ask Philip about this.
Okay, I'll take presenter to me for that purpose. And okay, this is some brief wall example where I can show, for instance, in stress, I switch off the reinforcement, that we can draw the mesh, right? So since 9.0, you are able to show the mesh. And also there is one small setting in setup which can multiply the default mesh size. It means that also you can see in tooltip, the 0.5 is the finer mesh, and let's say 2 or bigger is the coarse mesh. So for instance, if you want to see how I can change and to speed the calculation, I will change the 2, because for instance, I'm just tuning the whole setting. Once I change that, you can see that my results are gone. And so the recalculation will be much faster. So let's say in a few seconds, we will get these results. And of course, we can see that the mesh will be much coarse. I also was in the PowerPoint presentation, so now you can see that we are calculating the short-term, now the long-term parts of these combinations. And you can see that the mesh has been adapted and the user don't need to do anything, but the software did that. And for both the concrete, and you can see that also the reinforcement has much bigger size of the mesh element, as they are both dependent of that setting. I hope this was enough explanation, and we can continue to second one.
Okay. Okay, I can see here another one. The user asks if it is possible to input a load only on a part of a member. This maybe can show us Jana, because it was also related to her example.
Okay, yeah, I will just show it in my example. So it is possible to define load only on a part of the beam. So if I go to loads in the tree, I can, for example, in load case LC2, add another load impulse in form of line load. So I will change the value to see it better. So now is the orange one in the picture, and I can change the position from the whole length on part of the edge. You can see that I can define the X position of the load and also the length, so it can be it can look like this. And another possibility is to define it not from beginning but from end, so you can see that it's a variable. You can define the load as you need.
Okay, thank you, Jana. I think that's all. I don't see another questions. If you have some another questions, you can feel free to send us by email, and we will answer that after the webinar. Now, just let's go to the just to finish the webinar. At the end or after the webinar, you will receive a form. So about a few questions. So I would like to ask you to fill or answer us these questions. It will help us maybe to improve another webinar. We will provide you a recording of this webinar, so we will put it on our web page, so you can check it or see it again. And if you would like to test the Idea Statica version, so please feel free to download the trial version and the activation code, as I mentioned during my part of the presentation. I would also like to remind you our resource center. So we have a resource center on our webpage. When you go through many tutorials, verifications, and other useful materials, you can also check the recorded webinars from the past. And I would like to also mention that we are preparing another webinar which will be about the new development in Idea Statica 9 for the steel. So that's it. Yeah, here's just a screenshot about our new resource center. We also, because we have changed the content of the resource center for the version 9. So that's it. Okay. So thank you for your attention, and I'm looking forward to meet you on our next webinar. Goodbye.
Goodbye.
Have a nice day.